Hello everyone. Today I will going to lecture. I'm going to deliver a lecture on in situ stress and lateral earth pressure. So let's start from in situ stress. Here is the in situ stress. So we have been seeing the soil profile is given here. At the upper portion is a water and lower portion is a soil. So how we will get the gamma equal to GS? Uh, gamma. What I will say? Sigma equal to gamma is if we know stress equal to force by area and force we equal to W equal to B into G and found in this here in area is here area is remain gone and then sigma equal to gamma is okay. Let's see the effective stress concept. So sigma equal to solid portion and plus water portion. So we know the sigma equal to total pressure and then effective pressure we know in the solid portion. Here the solid portion is gamma is, and another one is a U, which is pore water pressure, is the water. We have been seeing here various condition is a dry soil is a moist and partially saturated soil. Here is a saturated soil. So in this dry soil we have been seeing in the solid portion in upper portion is here. On the other hand we have been seeing the moist portion which is solid and upper portion is water and then here. On the saturated soil there is no water in between here. Okay. So let's see how we'll define when unit to height of soil is gamma, and when the soil is partially above from water level we say gamma prime equal to gamma. We know the total pressure equal to gamma effective pressure plus in water unit pore water pressure. If we calculate here, here is a water level, but we will calculate the above the water level, then we will calculate gamma equal to gamma will be there, because when soil is moist and dry, then gamma prime equal to gamma. On the other hand we have been seeing soil is partially below from the water level. Here is the water level. We can find out the this location and air. We know the total unit weight is gamma prime into B, and total unit we know the gamma into Z, and gamma prime into gamma sigma prime equal to gamma prime Z, and U equal to unit weight of water and Z. In this way we can see here gamma saturated equal to gamma prime equal to gamma. So we can if we gamma prime is taken in the left side, then we will find gamma prime equal to gamma saturated minus unit weight of water. So these are the basic condition in basic on location of the soil property. So when the soil property water is above, then will be gamma prime equal to gamma. When the water level is above the location, then we will do gamma prime equal to saturated into gamma. Okay, let's see the another an example for calculating total stress, effective stress and pore water pressure. Here the question is given in the question. So draw the total stress, effective stress and pore water pressure diagram. Okay, let's start. We have been seeing the first layer is the unit dry unit in 45.5 and moist 62.2, and then there is a soil portion and solid 17.2 and so saturated 18.7. So how we'll calculate? We know the first diagram is a sigma diagram. Sigma equal to gamma equal to Z. Here is a gamma is given 14 into Z equal to 2 meter and found 29. And then second layer, this portion how we'll get in gamma we have been 16.2 and Z equal to 3. Then we have found plus upper portion we have found at the first layer. Then we have adding this value and found 77.6. In this way we have been found saturated, which is 77.2 into Z equal to 7, then here, and adding this upper portion of value 77.6 and found 177.6. In this way, we have found the fourth layer, which is 18, is a gamma situ. It is given 18 into height is given 4.5, and 160.6 is upper layer, and then found 277. This is the diagram of sigma diagram. We have called here the total stress. On the and the second diagram, we have been found the effective stress, which is only we have calculated the effective stress. Let's see how we calculate. So 45.2 14.5 into 2 gamma into Z. Here is a gamma prime into Z. That will be gamma prime. There is no water, that's why gamma prime equal to gamma D. If there is water here in this way, we have been seeing the water here, then we are deducting the water value, which is 9.81. So let's see. In the second layer, we've been seeing 16.2 into 3, 16.2 into 3, and adding the upper portion of the value, and found 77.6. And this is the very important, which is found 7.39. How will get this? We have been seeing the value is saturated is given 17.2, but we have been find out the gamma prime. Gamma prime is gamma saturated minus unit weight of water. We know the unit weight of water is 9.81, and 70.2 minus 9.81 and found 7.39. That's why we will use 7.39 and multiply with 4. 4 is the Z, which is the layer of the soil. And then we are adding the upper portion stress, effective stress, and found 107.6. And in this way, we have been found we have another calculated 8.89. How will get? Here is a saturated is given 18.7, and we will deduct the 9.81, which is in weight of water, and found 8.89, and Z is 4.5, and this upper portion is and the upper effective stress 107 is adding here, and found 147.7. And last one, we've been seeing the pore water pressure. Pore water pressure, how will calculate? Pore water pressure will be calculated only below the water level. So there is a water level is indicating here only layer 3 and layer 4. So layer 3, we have been seeing the water level is here. We will calculate 9.81 into and the layer height is 4 is given here, and found 39.2. And the layer 2 also is 9.81 into 4.5 plus upper adding the upper value, and found 83.3. These are our diagram of the total stress. This is the total stress and effective stress, and last one is a pore water pressure diagram here. So let's see another example. Find the effective stress at the point A. Here is the point A at wall stresses. Okay, so sigma E gamma into Z. Here is a gamma. 14.5 into 2, here is a 14.5 into 2, and 16.2 into 3, 16.3, and 17, here is a 17.2 into 4, 18.3, and they have found 189.41. When we'll this is the total stress. When we calculate the effective stress, then we will calculate 70.2 14.2 into 2 and 16.2 into 3, and then this second third layer and fourth layer is below the water level. That's why we will deduct the water level. We have found 17.2 and deduct the 9.81, which is unit weight of water. And then number fourth layer is 18.7 and deduct minus 9.81, but we will calculate this point. So this point is located at 2.3 is given in question. That's why you will multiply 2.3 and found 27.607. And we will calculate pore water pressure. Pore water pressure is here from this layer to downward, which is 9.81 into 4 and 9.81 into 2.3, and from 61.606. Now we'll verify this. We have found total stress is 189.41, and effective stress we have found 17.607, and water pore water pressure is found 61.803, and adding two value is 189.41. So left side value and right side value are equal. So we can say these are the okay. So we can see another graph which is solve proper is given and plot the variation of the total stress in pore water pressure and effective stress of the graph. So we can see here at first we have been dry soil is dry soil. Gamma d equal to specific gravity into unit weight of water into 1 plus E is all the data is given here, and found 17.33, and moist soil, here is a moist soil. We have been seeing the GS gamma S and SE into G1 plus E, all the data is given here, and putting this value and found 18.91. And saturated soil we know S equal to omega S into GS, and found in this way we found the void ratio 1.138, and saturated unit weight will do GS gamma S1 plus EW gamma W1 plus E, and found 17.33. So now we'll get these three type of unit weight. So we'll put this value in our new diagram. Here is 18 and 17. Now we'll draw from this data, and we'll draw the total stress, effective stress and unit weight of water. So let's see, the total stress is 70.33 into 1.73, and found 29.83. It will be 1.83. Sorry, I have mistaken. And found 20.93, and the second one 18.97 into 0.91, and found plus, and the upper stress, and found 47, and in the saturated we have found 7.6 is an 1.83, and the upper portion, and found 17.9. When we'll calculate the pore water pressure, then we'll take the one when there is a water, then we'll detect the water pressure. So at first 17.3 into 3 we have already calculated 29.8, that's why we will not calculate again here, and 47 is remaining as we have calculated here. The in this portion only lower portion of the water pressure will be changed. So let's see, 70.66 minus 9.81. 9.81 is the unit weight of water, and 1.83 is the height of the layer, and adding the upper portion of stress, and found 61.6. And third one is pore water pressure. Pore water pressure is only for third layer. We have been seeing the third layer pore water pressure is 9.81, and layer height is 1.83. So found 70.6. Okay. So these are the basic. I have basic calculation. I hope you can calculate all things. So let's start another what I will say another chapter, which is lateral earth pressure, which is related to lateral earth pressure. Before I am going to lateral earth pressure, we should know some formula. Here is some formula. So I want to say that lateral when we calculate the vertical earth pressure gamma b, then we have used gamma prime into z. On the other hand, when we will calculate the horizontal, which is lateral or horizontal, then we will multiply a coefficient which is k. So k will be come out here at rest, at active case and active passive case. Okay, let's see. So I'm giving just introducing this, what is the difference between the vertical earth pressure and lateral earth pressure. When we calculate the lateral earth pressure, we just use the vertical into a coefficient which is k or kp or k naught. So let's see. As a three cases we can see, the at rest, active case and passive case. when soil is thrusting to the retaining wall, then we can say active case. Most of the cases are occurred in practically in active cases. On the other hand, we can see the passive case when the boat uh, um, or ship is trying to terminate here, uh, then the one portion of soil is stresses. That's why we will call the passive case. So let's see. And the cohesion less soil is gravel and sand. On the other hand, we have see the cohesive soil. So we will concern always cohesive soil. Remember this, because the in this world, many in the 90% our building is built on the cohesive soil, which is silt and clay. On the other hand, cohesion-less soil is sand and gravel and sand. Gravel is not there, but sand is shared. So we can see at rest condition, gamma A equal to gamma prime B 1 minus sin phi into gamma is. In active cases, the formula will be K into gamma prime D, K equal to 1 minus sin phi divided by 1 by sin phi into gamma is. On the other hand, we have seen the cohesion-less cell will be K into gamma is minus will be 2 C root over K. On the other hand, we can see the passive case, which is K into gamma prime B, and the in cohesion-less cell will be K gamma prime means plus. It will be plus always 2C plus K. So there is another relationship between Ka plus Kb, which is Ka equal to 1 divided by Kb. So we can say that the value of Ka must be less than 1, and Ka is 1 when the water is calculated. We have been seeing the previous lecture, which is over consolidated ratio, which are gamma prime P divided by gamma prime D equal to sigma gamma. So here is some example is given, the cohesion-less soil, which is free running type of soil. On the other hand, cohesive soil, which is silt and clay. So let's see. Here is the case 1, case 2, case 3. Case 1 is the active at rest condition. There is no pressure occurred on soil, and we can say the retaining wall. On the other hand, we can say the second case, which is active case. Active case, the soil is thrusting on the what I will say is a retaining wall. That's why this is the active case. On the other hand, we can say the last one is a passive case. When the retaining wall or someone wall or something is thrusting onto the soil, then we will consider this soil is passive cases. Okay, let's start. So I have been seeing here another relationship between K into gamma is into gamma prime, and then here so case 1, case 3. So here is another graph. We can see the passive case, the wall tilting is left side, wall tilting is right side, and this is the vertical earth pressure is horizontal, and the passive case pressure is intersect here, and rest condition intersect here. So these are the formula I have already shown you, clarify you, but I am saying again because the formula is very important. When the rest condition cohesion-less, that means sand, and cohesive, that means silt and clay. Silt and clay is mostly used in over the wall, so that's why we will consider this formula very deeply. So we can say that rest gamma equal to gamma is not equal to K not equal to gamma prime B, whereas K not equal to 1 minus sin phi. On the other hand, we can say the active case gamma is A, which is horizontal active, which is K coefficient of K active into gamma prime B vertical, and gamma HB will be for silt and clay, K and gamma P minus, it will be minus 2C root over K, and K is nothing but the coefficient 1 minus sin phi divided by 1 by sin phi. In the same way, we can calculate the passive case gamma Kp into gamma prime B for cohesive soil, which is silt and clay, Kp gamma pi and b plus, it will be plus, so 2c root over k 2c root over kp, and kp equal to 1 plus sin phi minus 1 by sin phi. So remember that the passive, we can see from this formula the passive value will be greater than active value. So okay, here is the soil. You can see here, I have already mentioned, and I have already said this formula, so I will not say again. So you can see here another formula is common, Ki equal to tan square 40 minus 5 by 2, and another one is Kp equal to tan square 45 10 minus 2. So we can use either this 1 minus sin y or tan square 45 minus sin phi by 2, or we can use for case 1 plus sin phi or tan square plus 45 plus 5 by 2. So both are the same, so don't worry about this. So in this condition we can see the Kp value is greater than K naught and greater than K active. Okay, so let's see an example. So example is given here. You can see here the soil profile is given, so we can use the horizontal diagram, which is K vertical into K coefficient of active cases. So we can see here K is given here, which is I have already calculated here. Before I am calculating here, we can see the Ka 1 minus sin pi plus 1 point sin pi, which is 0.27. So 0.27 into 47.1 and found 12.75, and here is a 20.75, and the second point we can see here the 0.117 is the second value of angle is given, taken 45 and found 17 and 47.5, which is lower value 4.2, and then third one we can see 0.17 from this angle and 61.8. How will get 61? This is the, at first we will calculate this diagram, which is called sigma vertical. So sigma vertical 3 into unit weight of soil, and found 47 and 47 plus 1.5 into 19.9.81 is 19 is given, minus 9.81 because the water pressure is given. That's why you will found 61. So I will solve this. At first we will draw this sigma b, then we will calculate the K and Kb. This is the second graph, and this will be third. It will be our third calculation. At first we will calculate the sigma b and found the value of K, and calculate all the value and found K into gamma b equal to 12.75, and K into gamma pi b and found 8.02, and in this sequentially we will get the third point, which is 0.17 with respect to the value angle of the soil, and it will be multiplied with say 61.8 and found 10.4. So we can and then we will use the another and then we will go for this calculation, which is number 4. We can denote it the number 4, 2 into root over cy root over kh, and we'll use this, and 2 into c into root over k2 will this, and these are the 2c root over k diagram. This will be our number 4 step, and found 5 and multiply, and we will be found 5, and it will be maybe 4, and putting this all the diagram, and then we will calculate the sigma effective diagram, which is 3 into 1.5. We know the 3 into 15, and here is a 3 into 15.5, and then last one 47 plus 1.5 into 19 minus 7, and found there. and this will be our number 6 step, which is pore water pressure. We know the pore water pressure is here, so we will only calculate the pore water pressure portion and found this value, and that will be our number 7 step, and this will be uh, horizontal pressure area 1 2 3 4 5 6. So this we can say area 1 2 3 4 5 and 6. So area 1 2 3 will be plus, here is the area 1 2 3 will be plus, and we will calculate, we will deduct or we will minus the crack portion, because it is the active case. Soil is thrusting to the foil. We have shown here in active case the formula will be this, minus 2 C, but that's why we will minus 4 minus 5, we will calculate minus 5, and minus 6 also, as pore water pressure is here. And in this way we will all the value is given here, and found the pressure diagram. Okay, let's see here. Here is a very crystal clear example. For the retaining wall is shown figure, determine the force per unit length of the wall. Rankings active state is the active state. Also find the location of the resultant. Okay, let's see. Here is the wall data in here. Equationless soil. So sigma b is, we have drawn firstly sigma b graph. How we get gamma effective gamma into z, and putting this value, and then we will calculate Ka, or coefficient of active case. This is our second step, and then we will calculate the third step. We will draw the horizontal diagram, which is K into gamma horizontal, so gamma vertical. So how will find this 0.33, which is K, in 0.48 we will found the previous diagram, and then 0.27 is for this second layer soil, and 48 is also upper in the previous diagram. In this way we will found the number 3.27 is a active coefficient in second layer, and 72.5 we have found 72.6, sorry, and found 19.6, and this will be our fourth diagram, which is pore water pressure. Now we will get the number 5th step. We will sum all the area here, area 1 2 3 4, and found all the active pressure 115.5 kN, and this is the second 6th diagram, which is moment, force into perpendicular distance, area into distance. We will take A1 into D1, A2, D2, A3, D3, A4, A5. See, this is the A1, 2, 3, 4. In this way we will calculate all this area and found the unknown value Z, which is 1.7.5 meter is bottom. So this we can see here is a diagram 115 is a lateral force acting upon the 1.75 of the bottom. So you can see another example here is given for the retaining wall shown, and determine the force per unit length of the wall active cases. So as the active also I can find the location of the resultant also. So all the question is given. So at first we will calculate here the vertical pressure, and then we will calculate the coefficient of active case. Here is the second, and then third we will calculate, we will draw the horizontal diagram, which will be Ki into vertical. Ki is 0.33 and vertical 0.44. 0.33 and 0.44 will be 15. And we have seen the second angle, and the coefficient of active cases 0.27 and 0.47 will be 13. And third point we have been found 0.27 into 70.9. And then we will calculate the pore water pressure also here. The pore water pressure is indicating here the second layer also. And then finally we will calculate the 2c root over Ka diagram, which is we will calculate the here. From here we can see 2c root over Ka and found 5.14, which is 5.74. and then 10.39. 10.39 all are the negative. Why negative? Because we have seen the uh, in the formula here, in active case is 2c root over always negative, in passive case is positive, but we will calculating the active case, that's why we will see the all the negative cases. And the force, we will know the sum of the all areas, which is 1 2 3 4 5 6. 5 6 will be minus, I have already said that, because it is active cases and it is obviously silt and clay, that's why we will use this. And a1 a2 a3 a4 minus a5 minus a6, and putting all this value and found force 67.15. so 67.15 is here. And now we'll find out the location, which is a moment, force into z, sum of area into distance, and we'll multiply all the distance in the respective area, and we'll minus only the portion of 5 and 6, and it will be also respective distance, and in this way we found the location of the resultant force from the bottom of the soil layer. So here is our another solution. So let's see another solution, so which is given a frictionless. So frictionless soil, I can always say that this is the clay, and retaining wall is shown is figure below. Here is a below profile is given. So we have to determine the active force after the tensile crack is occurred, and the pressure force also we have to calculate here. So you can see the soil profile is given here. From this here we will start from the coefficient of active cases 1 minus sin phi divided by 1 plus sin phi, and found 0.39, and z we are know from 0 at the top. And we can see we will calculate the horizontal cases, so we will use direct formula, which is k into gamma vertical minus 2c root over k. So k we have already calculated here, vertical we are known here 15 into 4, and found the 10, and 2c root over k. C is we have found the value of c, and k value found is 0.39, and found the gamma horizontal, which is 6.09. 6.09 is here at the upper portion of the soil layer. And now we'll calculate the these are calculated for when z is 0 at the top. Now we'll calculate when z is 4 from top. So we will use z value of 4. So k, we know the value of k 0.39, and gamma is equal to 10. We know the value of 10, and then we will adding the sum value 15 into 4. Here is a 15, which is soil unit 1, and 4 is the height of the particular layer of soil. And then subtracting some crack value, we know that 2c root over k, and which is the 9.9999, which is almost a 10, and ultimately we have found the results in 70.31 kilonewton per meter square. Here is the soil profile, but it will be our reminder that the value is the depth when the depth is 4 meter below the soil. And from diagram, from similar diagram, here is a similar triangle diagram. We will calculate 6.09 equal to ZC. Here is a 6.09 equal to ZC, and 7.31 into Z minus 2C, and we will found ZC equal to 1.04. So this depth of tensile crack we have found the 1.04. After the 1.04, the cracking of the soil will be appeared. Okay, so after the tensile crack occurred, and the force will be half into length into height, which is a basic formula given by Pythagoras. and we'll putting half and base we have known here 70.31 and z minus 4. So we are know the total value of 4, so z will be deducted because we are calculating this portion and found 25.62 kilonewton. So another, this is the tensile calculus will be all by 25.62. This is an answer. Another one for the passive case, 1 minus sine 1 plus sine phi 1 over sine phi, which is z is 0, and the passive case this will be plus and found 51.2. And then second condition on z equal to 4, and in the passive condition this will be plus and found 204.4. The passive per unit length of the wall will be the diagram of this, that's why this will be trapezoidal and this will be rectangular. So trapezoidal 4, here is a 4 and 51.5 is here, and plus this portion half into height is 4 and length equal to 240 minus 51.5, so 15 kilonewton per meter. So let's see another example which is given. Apply the Rankine's theory of the location of pressure for the following question. Compute the magnitude of the force per unit length acting on the retaining wall. This means is active case, and shown in the figure backfill soil or push in the retaining wall. So push into retaining wall, this means in active cases. So consider up to the degree of line. Okay, and calculate the different lateral force in the active cases if soil is both layer have a 10 kPa equation of the depth is okay. So all the data is given here. At first we will calculate the gamma vertical, which is gamma into gamma prime into z or s. How will say. So 41 we have seen 14.5, and then height equal will be 3.5 and found 51, and 51 plus and 16.8 into 2, and in this way 60.7, and then we will calculate this coefficient. So it will be our second case, and this will be our third case. Now we will get the horizontal stress, which will be gamma k into gamma b. K is found 0.425 into gamma b is 51.5, which is 21.74, and this where the second layer will be 0.36 into 41.5 and found 18.4, and the third one will be 0.36 into 16.7, which is 40.14, and this will be our fourth, which is prorotor pressure, which is only given in this question here. So it will be 9.81 into 2 meter, and lastly we will calculate the crack portion 2c root over k. Here is a 2c root over k, and found all this value. In this way we will calculate this is our sixth step. The force will be area of the soil, area 1, area 2, area 3, area 4, and found 100.6 is keeping, and we see the minus 2c root over k. All the for 2 portion we have calculated here. This is our seventh step, and this is our final step for active for horizontal pressure A1, A2, A3, A4, A4 and minus A5, A6, because this is the active cases in we have to calculate for while we calculate the soil is considered the silt or clay, and different of the location is found. We have seen here 100 minus 31 and found 69 points. So no the force will be decreased. Force will be decreased. And we have seen here, if the backfill soil is pushed in the retaining wall, and find the magnitude of the force per unit length of the retaining wall shown in the figure. Consider up to the dotted line in the perimeter is B. calculate the change of the degree of the equation, and all the value is given here, gamma d, and we will calculate at first here gamma b, which is stress, effective stress, which is gamma prime into z, and gamma prime into z, and then we will calculate the coefficient, which is k, and we will draw the diagram here, number step 4, which is gamma prime h, which are k into gamma b. K we know 0.3 and gamma b is 0.46, and found in this way calculating here. And then we will draw the number 4 is the water pressure, which is only water pressure into 15.5. we have known the water pressure is here, water pressure into 5.5, so water pressure into 5.5, and we will calculate the numbers. 6 is 2 over k active case, and in the active case we will see another into 5 over k, and we are calculating for this way 1 minus sin phi and 1 cos sin phi. In this way we will calculate 2 over k, which is 13, and gamma horizontal will be 1, 2, 3, 4, all the plus and minus 0.5 and minus 5 and minus 6. So minus 5 and minus 6 in the active cases. That's why we will minus here, and found the horizontal force 139.43. Change in active force, which 147.79 in 139, which is 39, which is 38 kg. The depth of cancel is ZC. We will calculate here. Here the another graph is calculation is given here. So you can see all the calculation we can found here. So let's see another example here. This is the very crystal clear. We can see here the frictionless soil, which is clay, and the retaining wall is shown here. Determine the active case potential crack is occurred in passive forces also. So at first we will calculate active cases k 1 minus sin phi theta is found. When z has h equal to 0, then we will found the stress equal to minus negative 0.60, and at the bottom layer when 4 we will calculate the stress 14, and for similar triangle we will calculate z equal to 0.4. In active cases the tensile crisis is 14, and the passive cases we know the cap is here, and from 0 we are z is equal to 0, then 51.2, and the a is equal to 4, then 204.4, and in this way we found, and passive case force will be 512 kN. So we will go the another example is here. We can see, okay, from here determine the location of the crack of maximum unsupported backfill is here. We can see that theta equal to 45 into 5/2, or we can 1 minus sin phi by 1 plus sin phi we can use, then we will use 50, and PA equal to z plus cos theta by 2, and at crack when z equal to PA pressure is 0, then we find the z equal to 0.31, and maximum length of the unsupported backfill will be 7.72, and we will case 47. This all the diagram is here, is given here in location. So we can see another calculation here. We can see that theta is 45 and k equal to 1. If you use 1 minus sin phi by 1 plus sin phi, then we will see the value will be 1, and k when the z equal to 0, then we can found the stress minus 40, and when z equal to 6, then we can found the stress 49, and for 1 we can see the stress equal to 0 and z equal to 1.21, and for 2 up into land into height and found 177, or in this way you can use there, and from 3 up into h into 3 and found 189. So another calculation here, the retaining wall is soft, is here the pressure after crack. So we can see all the formula is given here, 1 minus sin phi by 1 plus sin phi, or we can use 5/2 into 40, it will be 1. For height, which is stress 0, then h equal to 1.21, here is 1.21, and sigma naught equal to minus 40. So minus 40 will be 121 and minus 6 is will be 79. 79 will be where 4.99. Okay, so the pressure of the after crack will be up into P6. This is the P6 and H minus AC. H minus AC, that means 4.47. 6 minus 1.21, that means 4.79, and found 189. In this way, pressure before crack we have seen half into S into AC, which is 1.1, and this and half into AC, where is AC into H minus AC, that means 4.47. 6 minus 2 minus 4.79. And calculate another we can see another graph. You can see they calculate the lateral force while we withstand the backfill assume the smoothie. So all the data is given and we are using this and found this value. So we can see here another retaining wall is condition following the determine the lateral pressure, and following figure is given. The figure is given here. So theta is found 50 and K is found at z equal to 0.31. Now when the z equal to 0, then stress equal to minus 47. When the z equal to 9, then stress equal to 67, and T equal to half into height minus Z, that means this portion, which is 5.2 and 60.5. Okay, so we can see another way. Find the lateral force of the retaining wall is given is here, and figure below wall is rest. So K equal to 52 and lateral force K gamma is half into and found 50.7. So the another example is given here. So tensile calculate to calculate the before the tensile and after the tensile. So K we know the 1 and the depth of tensile. When the stress 0, then we will found S equal to 7 feet here, 7 feet, and stress equal to 0, then found 700, and stress equal to 20 and found 3099. Before cracking, half into stress naught and AC that means here 7 feet, and half into stress 20, 30, and then this side 20 minus 7, which is 30, we know 30 here, and found 6000.3. And pressure after crack, what will be this portion, up into 20, 13.9, and H minus 20, which is this. So that means this portion is after crack, and the before crack will be 2 portion. Okay, let's see another example is given here. The confined cushion soil is determined the depth of the excavation without support. You can see here. You can see another question is found here. The retaining wall is height is active in the wall is non-cohesive soil is given is here, and find the top out the resultant force of the parameter. So K equal to 0.33, K and 0 stress is 0, and height is given is 6 and K2, and found 6 into F is 17, and A is equal to found 13.3, and horizontal half into land into height and half into land into height, and found it. And the location pressure force equal to moment equal to force into perpendicular distance, and that will be Z equal to unknown A1 D1 A2 D2, here is A1 A2, and found Z equal to 3.56. So another example, you can see the soil layer is having perpendicular is given all the here data, and vertical is there, and tau equal to 2 C root over 10 phi, and found the soil stress also. So here is I calculate the earth pressure and location of the activation in this condition, and we can use this formula also, we have already said. Another example, you can see the retaining wall is shown here, determine the force per unit length and location of the resultant. So these are the first priority, and then we will calculate the second, and then we will go the third condition, and fourth will the pore pressure, and fifth will be the crack and uncracked faces, and 7 will calculate the force, which will be the sum of the area 1, 2, 3, and 4, and found 509. And movement will be force per perpendicular distance, area into distance, and from z equal to 1.9, 1.9, which is the bottom. Okay, so we can see another the tensile crack we have already shown here. So these are the today's lecture. If you have any question, then let me know. So before I am going to leave, you must be some memorize this formula for uh, for um, uh, lateral pressure. Mm. And these are also 1 minus sin pi by 1 plus sin pi over 10 10 square 45 sin pi. You can use also this formula. Okay, so if you have any question, let me know. Thank you.